Now, the outline for the presentation, we will start with a brief introduction on robotics. After that, we talk about robotic applications, example and facts from healthcare. We move to talk about robotics in the Arab world. After that, we mention robotics toolbox for technical innovation. We focus on design and build of unique robots, and mainly we will be discussing robot swarms and system of systems. After that, we provide a few tips for young innovators when talking about robotics. First of all, as a terminology, well, we know that a robot is a system that contains a lot of sensors, control systems, actuators, and power supplies, and can be programmed to do more than a certain task. Basically, the difference between a robot and a machine is that the robot can be programmed to do a lot of jobs, whereas the machine is usually programmed to do a specific task. Now, when we talk about the robotics, robotics is usually, it's the science behind the robots. It's usually talks about the design, the implementation, the operation, and the application of robots. Now, of course, it's ordinary not to have a certain person who knows everything in robotics. So mainly, it's usually not the case that any single person that has all the information for robotics. That's why a partitioning of the field is very important in order to be able to approach. So you can approach robotics using mechanical manipulation, locomotion, computer vision, or artificial intelligence as an example. Now, example of usage of robotics in healthcare. We know robotics have been used in surgery. An example would be the Da Vinci robot, which is programmed to be able to do operation with a lot of advantages, such as high precision. It has stepper motors that can move with a precision of 1 microdegrees, and it is error-free, which means that it can do operations with a lot of precision. Now, of course, we have also robotics that are implemented in telemedical network. When we say telemedical network, which means that we are able to supervise medical operations, such as draw of blood using the network itself and specific robots. Now, also, we can use robots, let's say, as an example, as exoskeletons. When we say exoskeletons, it means that robots can be used to support humans. Now, those humans can be maybe paralyzed, or also troopers in the army are using also exoskeletons to provide additional power during combat. We have also disinfectant robots, which are used at hospitals to disinfect infected rooms. And also we have pharmabots, which are basically used to deliver, organize, and bring medications in pharmacies. Now, a few facts about robotics in healthcare. Now, by 2020, the surgical robots investments is almost expected to reach up to $6.4 billion. Now, a 70% drop in hospital infections, which is acquired due to the usage of the Xenix robots. We have around 7,500 operations in telemedicine that are performed in clinics. Also, we have robots that are able to carry around 400 kilograms of medications. And also we have microbots, which are very small-sized robots that are able to deliver a drug through the bloodstream. And also we have VBot that draws blood in less than a minute. Now, those facts are basically just to give you information about applications of robotics. I chose healthcare because robotics are widely used in healthcare nowadays. Now, robotics in the Arab world, what is the current situation? Basically, the term robot or robotics is trendy nowadays, and we all know that the reason is that people are starting to get the proper information to be able to learn, and they like to watch and see robots in operation. Now, tens or maybe hundreds of communities, summer camps, competitions, and conferences about the subject are available in the Arab region, which is a good indicator that the term is becoming more and more trendy in the Arab region. Now, basically, an important aspect about robotics is that it's nowadays approached at different levels of knowledge and practices, which means you find students at the school level that are ready to work in robotics, in specific at a low level of knowledge or details, and you may find people who are even not in schools that are trying to learn how to approach robotics. Also, you can find a detail or a high complexity of projects in robotics in universities and also in certain contests. However, this does not mean that we exploit robotics very well in our Arab world. There are several reasons which need to be addressed. Specifically, there should be some sort of strategic governance to be able to exploit all the benefits of robotics, to be able to implement robotics in education system, to be able to benefit later on in the industry. Now, basically, when we talk about robotics, it's very interesting to realize that robotics itself can be a toolbox for technical innovation. When speaking about robotics, we can usually discuss several sciences that are related to the field. Here, what I want to say is that it may be very difficult for you to learn all the sciences or to learn all the knowledge behind robotics. So what could be done here is that you can choose a specific aspect of robotics to be able to implement your project in. Now, what I want to talk about today is not building and design of unique robots, because it might be beyond your scope and beyond the context of your knowledge. But as an example, there are several unique robots, maybe hundreds or thousands, that are being developed worldwide. Each one is specific in its type and operation. Here we can see example of Spot, Valkyrie, Gita, and also the octopus grips. They are just examples to give you a notion about unique robots that are being developed nowadays. However, we want to talk about two different terms today to be able to benefit from them. And those two terms are the design and build of robot swarms, and also we need to introduce to you the context of system of systems. So our main focus will be on those 2 points. We start with robot swarms. Now, basically, a robot swarm is a large number of robots that are working together and trying to achieve a common mission. Now, the background for robot swarms comes from basically animals. We can see all the time how animals live in a swarm. They have a big advantages over animals that do live alone. Now, when we talk about swarm, we mean a large number of robots that are trying to cooperate effectively in order to process a mission that is beyond the capability of a single robot by itself. Now, basically, the concept of robot swarms have been applied in agriculture, in search and rescue operations, in security and defense, in surveillance and situational awareness, in object manipulation, and in also intelligent transportation systems. Now, speaking about robot swarms, what are the terminology that we need to know about the swarms? First of all, species represents the types of robots that are available in a swarm. If only a single type of robot is available in swarm, then it's said to be a homogeneous swarm. Other than that, it's called heterogeneous robot swarm. Now we have the traits, which is the capability of a robot. Now basically, the trait is important to determine what type of robot in the swarm can be chosen to achieve a certain task. Now the anonymity, which means that not a single robot has a specific role that he can only do in the swarm. any robot can be replaced by another robot during the swarm to do the same task. Now also decentralization is very important, which means that there's no central functionality in any of the robotic systems available in the swarm. And hence, when we think about a controller to work in each of the robots, we have to think that this controller should be suitable to be implemented in whatever robot within the swarm. Also, uniform modularity is a very important feature of robots, which means that basically when we build robots, we take modularity into consideration, which makes building robots more effective and also easier. And also the stability, which means that each robot should be able to operate within the swarm and to carry successfully all the indicated tasks. And also the safety, which means that robot should be able to maneuver together within a swarm without any collisions. Now basically, robot swarms, as I said, are of two basic types. Homogeneous, which means that all robots are identical and they are made of one species, or heterogeneous, which means that we have several robot types available in the swarm. Now remember that heterogeneity is an important feature in robot swarms because you need to be able to execute a complex task, a different set of traits. If all the robots have the same traits, it would be difficult to execute complex tasks. Now, speaking of robot swarms, what are the challenges? The challenge is always at the design level, which means how you are able to design your swarm in a way to exploit all the possible advantages. Now, the main questions when designing a robot swarm would be, what robots are allocated to which tasks? The need for centralization of certain aspects to permit higher level of interaction with the human operators. Remember that robots in a swarm should be able to operate independently. However, we do need interference from humans, from the operating personnel at some cases. Now also, the decentralized overall design of robot swarm is very important, which means that no specific robot has a certain important role over other robots. And also, all robots should be autonomous within the swarm. Now, the perspective when we build a robot swarm is to be able to design the swarm in a way so that the human operator can take control of any robot at a certain time if needed. Now we move to talk about system of systems. Now the terminology for system of systems comes from literature. Basically, it's a concept. It's not something physical. System of systems is a concept that represents a coalition or a group of component systems that are cooperating together to achieve a common task, which is beyond the capability of each one of the component systems. Now, speaking of component systems, what they can be robots, they can be humans, they can be other component systems. So basically, the difference between robot swarms and system of systems is that in a system of systems, you can build a system that can include a cooperation between robots and other non-robot systems. Now, basically, the keyword system of systems, system means an organization or set, and systems means the component systems, which can be robots or humans. Now, of course, there are several fields of application for system of systems. Nowadays, it's being implemented in military, space exploration, intelligent transportation, and also in environment and space explorations. Now, the requirements of a system of systems are 5, which means that not every complex system can be regarded as a system of systems. For example, the car is not a system of systems. It's rather a complex system. Now, what are the requirements of a system of systems? First of all, operational independence, which means that each component system shall operate independently over the other. Also, we have the emergent behavior, which means that component systems should be able to be replaced when designing a system of systems at different intervals of time. Also, managerial independence, which means that component systems should be managed independently of each other. And also we have the geographic dispersion. There should be no physical contact between the technological component systems that constitute the system of systems. And finally, cooperative behavior. And here is a very important feature. Why? Because when you design a system of system, you get a system that has a capability beyond the capability of each one of the constituting component systems. Now here is an example of system of systems and intelligent transportation. We take an example from seaport terminals. So we have several component systems that are technological and non-technological, but in this case we focus on the technological component systems. Now here, a good thing to mention is that the component systems do exist in multi-structures, which means we may have various types of component systems that are cooperating together, and usually they are dispersed over different levels. At level 0, we have the physical component systems. Beyond level 0, we have the coalition or grouping of the component systems that are trying to accomplish complex tasks together. Here, at the highest level, we can talk about the system of systems, which represents the cooperation between all the technological component systems trying to establish a common mission. So as we can see, when we talk about system of systems, we have multi-structures, we have multi-levels, and also we have multi-missions for each coalition or group. Here is an example taken from Seaport Terminal, which represents IAVs that are trying to maneuver inside a confined space in a seaport terminal. Now I end by a few tips for young innovators who want to work on robotics. Now, first of all, if you want to work on a certain project, it's very important to define the project context and the problem statement, which means before you start working on the hardware, on the software, or whatever, do understand what is your problem and what is the problem that you are trying to solve, and how do you think your solution will contribute to that problem. After that, do a thorough research on your context, on your problem statement, to see how other people have tried to address this project in order to be able to not rebuild the wheel again, but do some original thinking, trying to make something new. After that, try to consult and discuss your ideas with your mentors, with your university instructors, with somebody who is knowledgeable on the subject. It's always good to share what are your ideas in order to get the best practice. Finally, get support. Here, what do I mean by get support? Whenever you choose a certain project to work on, do take into consideration that you don't need to know technically all the details. At some points, you might be a doctor or let's say, for example, from a medical background, and you need to do something that is technical related to microcontroller systems or whatever. For that part, you don't need to learn everything from scratch. You can always get support whenever you need to do your project. Thank you.